parametric functions. I'm going to give you a well-known example of parametric function. We will take circle because circle is the one everybody learned. This circle which I'm drawing, the circle which I'm drawing is a standard circle. And equation of the standard circle is x square plus y square equal to a square. This is called Cartesian equation of circle. Now imagine a point here, anywhere on this circle. It makes an angle theta with the x-axis. Then the coordinate of this point would be a cos theta, a sin theta. Should I explain this further or is it fine? Should I explain further? As I change the value of theta, every point on the circle will be defined. So to define the coordinate of any point on the circle, I can say x coordinate is always a times cos of the angle and y coordinate is a times sine of the angle. This is called the parametric equation of circle. Just to recap what I taught you once upon a time. Is understood the meaning of parametric equation? What is the parameter here? What makes different points on the circle? Changing which value, I'll get different points on the circle. Which value should I keep on changing to get different points on the circle?
Theta.
Theta. So theta is called the parameter. Understood? So by we call any point like in parabola. In parabola, can you tell me what is the parametric equation of this parabola? X coordinate is always
80 square.
80 square. And y coordinate is always 280. What does the t stands for? The reciprocal of the slope of the tangent. 1 by t is the slope of the tangent. Remember, no? We have done this.
Yeah. Yes.
So everywhere the parameter has some or other meaning. For example, here parameter is this angle for circle. For this one, parameter is reciprocal of slope. So everywhere parameter has got some sort of meaning. Now, what we are trying to do in this exercise is, if the equation is given in parametric form, how will you find its derivative? So I'm going to teach you two methods. I hope all of you are paying attention. So if x equal to a cos theta, you can also write with me. Y is equal to a sin theta. First question, show that dy by dx is equal to tan theta. Now cot theta minus cot theta. Dy by dx is minus cot theta. Second question, show that dy by dx is minus x upon y. Two ways question can be asked. Now one is third method also is there that I'll explain after this. So this type of question, this exercise has two types of question. One, derivative is expressed in parameter, in terms of parameter. In terms of Cartesian equation, that is in terms of x and y. In terms of x and y. I'll write it properly. What is this one? In terms of x and y. Okay. So if the question is in terms of parameter, then what we do to find out dy by dx? X is a function of theta and y is a function of theta, because when theta varies, x varies. When theta varies, y varies. So what I'll do is x equal to a cos theta. I'll differentiate with respect to theta. Because the variable is theta, I can only differentiate with respect to theta. So dx by d theta is a into d by d theta of cos theta. That is minus a sin theta. Then I'll take y, a sin theta. Then differentiate again with respect to its variable. So dy by d theta is a into derivative of sine theta. So that is a cos theta. Then dy by dx is, this is the important thing, dy by d theta divided by dx by d theta. Differentiate y with respect to theta, differentiate x with respect to theta and divide. So your answer will come a cos theta upon minus a sin theta. And you get minus cot theta. So answer remained in theta only. If you want the answer to be in x and y, so much is clear, everybody? If you want to get your answer in x and y, one method is a cos theta can be replaced by x, a sin theta can be replaced by y. But so easily every time you may not be able to get it. In that case, what you do is remove theta before we differentiate, before the derivative. Okay. So how will I remove theta? How do you remove theta in this case? How do you form an equation with this without theta? Remove theta means form an equation without theta. That is, form an equation in x and y without theta present. So naturally, I'll apply cos square theta plus sin square theta is 1. Cos theta is x upon a. Sin theta is y upon a. I'll simplify for my convenience. So I came to the Cartesian equation. So if you eliminate theta, you will come to the Cartesian equation. Now you will differentiate with respect to x. Why? Because you want dy by dx. So 2x plus 2y divided by dx equal to 0. Therefore, dy by dx is transferred to the left, minus 2x upon 2y. So you get your answer. Did you understand the two method? Have you followed the two method? If not, you must tell me. I'm going to ask you.
So 1 second.
Yeah, I'll give you time for writing. Just let's discuss later. Listen to me. Every problem in parametric function has two types of answers. One answer will have the parameter present. Another answer parameter is not present. If the parameter is present, what is the method of finding the derivative? If the parameter is not present, what is the method of finding the derivative? Is that clear? This is what you're learning in this. Is it fine?
Yes,
If
sir.
the parameter is present, you will apply dy by d theta divided by dx by d theta. What is the meaning of this? First, find the derivative of y with respect to theta. Find the derivative of x with respect to theta and divide. That gives you answer in the parameter. If you don't want the answer in parameter, there are two methods there. Either eliminate theta in the answer. After calculating the dy by dx, you can remove theta. Or remove theta before the derivative. That means formulate an equation with only x and y. If it is sine cos is there, then cos square theta plus sin square theta is the method to eliminate theta. If second tan, sec square theta minus tan square theta is the method to eliminate theta. Like that, depending on the question, how to eliminate theta, you have to decide. Is it fine? Anybody having doubt, please speak out. If x equal to 80 square, y equal to 280, show that 1 dy by dx is 1 by t. Second, dy by dx is 2a upon y. 2a upon y. I'm taking easy question in the beginning. All right. So first one, you want to answer in the parameter t. So what will be the method? Nandana, tell me. Nandana. Okay. Arunati.
Yes, sir.
What I want first answer, I want the answer in t.
Hmm.
So what should I do?
So we need to differentiate
Ah,
separately
with respect to which variable?
with respect to theta.
Yeah. In this question, it will be t because a parameter is in t. Understood that? Depends on
Yes,
the
sir.
question. So x is a function of t. So x equal to 80 square. Y is also a function of t. So differentiate this with respect to t. And
Yes.
differentiate this also with respect to t. After differentiation, what should I do?
We need to divide.
Divide. Excellent. Okay, start. Is it fine? Everybody?
Yes, sir.
Yeah.
Sir.
So the first part is this method. Second part is eliminate t. You can, yeah, there is a question here. Why only dy by dx? Why not dx by dy? Usually, when I say dy by dx, x is the independent variable. X is the independent variable and y is the dependent variable. That's why we always write dy by dx. But there's nothing wrong in writing dx by dy. And we are finding what? A rate of change of y with respect to x. Always one which is independent variable, the change occurs in x in first, then change occurs in y. That is the reason we always keep rate of change of y with respect to x. For example, velocity. T is the independent variable and this displacement is the dependent variable. So we write ds by dt. Here always x is independent and y is dependent. That is why dy by dx, x comes down. Is that clear? But if I ask you to find dx by dy, no problem, you have to take the reciprocal, that's it. So both our ways are right, but usually it is done that way by convention. Okay, now tell me how to eliminate t. We have with us x equal to 80 square, y equal to 280. How to eliminate t?
Take T as a subject.
Make t as a subject. So t is y upon 2a. And put it in this x equal to a into y upon 2a the whole square. So you will get the equation of parabola. So y square become 4ax. Now what to do after that? Y square equal to 4ax. What you must do with this? Differentiate with respect to x.
X.
So 2y into derivative of y is 4a into 1. 1, 2 got cancelled. So dy by dx is 2a upon y. Is it fine?
Yes, sir.
So these are the two methods to find the parametric function derivative. We'll practice more. So in this problem, we are not asked to show any particular answer. Find dy by dx. So your answer is going to be in t only. That means you're going to do only first method. So you will have to remember what is the method to differentiate x. Can anybody tell me? Can I differentiate directly or should I simplify? Can I simplify?
Yes, sir, you can simplify, sir. Instead of
What's the
t, you
method
can
of simplification? 1 minute,
Can I-
just one small error. The square is wrong there. Yeah. What is the method of simplification? How do you simplify an inverse function?
sir, instead of t, you can put sine theta.
Instead of t, you can put cos theta so that we can apply this formula. What is the formula? 4 cos cube theta minus 3 cos theta
Cos
is the formula for cos 3 theta.
theta.
Even if you put sine also, it's correct. It's not wrong. Only thing, it will come to sine 3 theta and then you have to change it back. So when you compare this, put t as cos theta. Then what will happen to x? Then x will become cos inverse 4 cos cube theta minus 3 cos theta. So cos inverse of cos 3 theta. I hope you are remembering this technique.
Yes,
So it
sir.
became
Yes, sir.
and theta stands for what? What is theta from here? Cos inverse t.
Cos inverse.
Cos
So dx by d theta and continuation of this. So dx by dt is 3 into d by dt of cos inverse t. So minus 3 upon root 1 minus t square. Again taking y is tan inverse, okay, root of 1 minus t square upon t. Now you tell me, what should I replace in place of t? Which formula? Root 1 minus t square. Whenever you see root, it will give you a hint to do the problem. What should be replaced instead of t?
cos.
Cos theta. Why cos? Why not sine? Very good. What is why cos? Let others also know why you took cos. Why not sine? Because if I replace t by cos theta, this numerator will be sine and denominator will be cos. So tan will come.
Tan.
Tan inverse tan can be cancelled. So you will put t as cos theta. Not because you put here t as cos theta. So let's use some other letter. Why we want to use the same letter? We'll use some other letter. So alpha is cos inverse t. So y became tan inverse root 1 minus cos square alpha upon cos alpha. Tan inverse of tan alpha. That became alpha. That became cos inverse t. Now dy by dt is minus 1 upon root 1 minus t square. I hope you remember the formula. Therefore, dy by dx is dy by dt divided by dx by dt. So minus 1 upon root 1 minus t square upon 1 by root t. Dy by dt is dx by 3 by minus 3 by root 1 minus t square.
1 by 3.
Oh, there's no space to write that. That's answer is 1 by 3. I hope you understood. So dx by d theta became a into 3 cos square theta into minus sin theta. Dy by d theta became a 3 sin square theta into cos theta. dy by dx became a into 3 sine square theta cos theta divided by a into 3 cos square theta into minus sine theta. So that became a cancel, 3 cancels. So that became minus tan theta. Is it fine? One square got cancelled with this sign, one cos got cancelled. Now we want dy by theta, theta is equal to pi by 2, pi by 3. So dy by dx when theta is pi by 3. That is minus tan pi by 3. That is minus root 3. Is it fine? Everybody, how many of you give the answer? Yes, Clevin has given the answer. Kashish has given, Varanita has given. 3, how you got, Kevin?
And I took the derivative wrong, sir.
Okay. Acha, you must have forgot to do that, this part. Am I right?
Yes, sir. Yes,
Yes.
sir.
Cos square theta into derivative cos theta, I would have forgot.
Yes, sir.
Okay. We'll practice one more question. I'll just pause for a minute. So first you took u. So remember, when you want to differentiate something with respect to something, call this as u, call this as v, and find du by dv. So you took u, differentiated with respect to theta by substitution, simplified, differentiated, and got equation 1. You took v, directly differentiated, then divided and got the answer. How to do this?
Take log.
Yeah, take log. Let u is equal to x raised to x, v is equal to x raised to sine x, and we have to find du by dv. Can you do this problem yourself, or should I give you time? Should I do it on the board? Do you want to try yourself?
Yes, sir.
Okay. Log u is equal to log x to the power x. Log u is x log x, differentiating with respect to x. d by dx of log u is d by dx of x log x. So 1 by u du by dx. X into derivative of log x plus log x into derivative of x. 1 by u du by dx. X into 1 by x. Probably you know this by heart, this answer. So equation number 2. Oh, Chirag, you have typed the whole thing. Superb, Chirag. Such a big answer, you have typed it. Du by dx. X to the power x into 1 plus log x divided by x to the power sin x upon x plus log x cos x. Very good, Chirag. You typed such a big answer. Good. Nice. The last question for the day. Differentiate tan inverse root of 1 plus x square minus 1 upon x with respect to tan inverse 2x root 1 minus x square divided by 1 minus 2x square. So as usual, let u is equal to tan inverse root 1 plus x square minus 1 upon x. And v is equal to tan inverse 2x root 1 minus x square upon 1 minus 2x square. So instead of doing it 2 pages, we'll do it side by side. What is the substitution you are planning for the first one? What is the substitution? Root 1 plus x square. What is the substitution? Parinita.
Tan 1 plus tan square theta.
Yes. And what about the other one, b? What is the substitution here? You have root 1 minus x square.
Cos, no, sine.
Sine. So you will write here, put x equal to tan theta. And here you will write x equal to sine alpha. Don't use the same variable, use different variable. Therefore, theta is tan inverse x. Tan inverse x. And here alpha is equal to sine inverse x. Now start substituting. So u is equal to tan inverse root of 1 plus tan square theta minus 1 upon tan theta. That is tan inverse of sec theta minus 1 upon tan theta. That is tan inverse of 1 upon cos theta minus 1 upon 1 up sin theta upon cos theta. So that became tan inverse 1 minus cos theta upon sin theta. That became tan inverse 2 sin square theta by 2 upon 2 sin theta by 2 cos theta by 2. That became tan inverse of tan theta by 2. So that is theta by 2. So u is equal to, theta stands for tan inverse x. So 1 by 2 tan inverse x. So du by dx is half into 1 upon 1 plus x square. That is your equation number 1. Here V is equal to tan inverse 2 sine alpha root of 1 minus sine square alpha divided by 1 minus 2 sine square. Tan inverse 2 sine alpha cos alpha upon 1 minus 2 sine square alpha. Sine 2 alpha upon cos 12. Tan inverse of tan 2 alpha. That is 2 alpha. That is V is equal to 2 sine inverse x. So dV by dx 2 upon root 1 minus x square. So we want to find du by dv. So du by dx is 1 upon 2 1 plus x square. dv by dx is 2 upon root 1 plus x square. So the final answer is root 1 minus x square upon 4 times 1 plus x square.